Number 6, the relationships on the previous page are shown as graphs. Which graph or graphs show exactly one output for each input, and which set or sets of data represent a function? Now, we already talked about this. Both graphs pass the vertical line test, right? If it passes the vertical line test, it is a function. In order to be a function, you have to have exactly one output for each input. So your answer here is that both have one input. Or actually, that should say output per input. Per input. And both represent a function. In order to be a function, you have to have one output per input. If it fits this requirement, that makes it a function. Number 7, think about the function related to dog licenses. Okay, that was the first one. Would there ever be 1 year that is assigned to 2 different quantities? Talked about this as well. Can we repeat a year because we didn't like the sales? No. Once the year is over, it's done. There's no do-overs. We can do better the next year, but we cannot fix the year that has passed. So your answer here is no, because we could never repeat an input. No input can be repeated. Okay, and that's just a logical thing. Okay, you can't repeat years, so there's no chance of this repeating and making it not a function. Number 8 says, look at your answers to problem 3 and problem 5 on the previous page. Can you represent either of the functions with an equation? When we talked about the number of licenses, we had a pretty good pattern at the beginning, and then we had a bad year, and then the pattern picked up again. Can we represent a pattern if the pattern changes? No. Okay, there's no way to fix this anomaly. So because we have 1 year that did not follow the pattern, we cannot represent this with an equation. It is a function. It is just not a function with an equation. But if we look at this dog years versus human years, we was able to identify a pattern and label it with data. We was able to say that each human year is 7 dog years. Okay, the pattern followed every time. So what we're going to put over here on number 8 is, yes, we said that the age in dog years is equal to 7 times the age in human years. Now, that's not an equation, but that's what the pattern said. We can fix it and write an equation by saying our output, y, is equal to 7 times the input, x. Now you have an equation that is predictable and repeatable. Substitute values into the equations to complete the tables. Then state whether the equation represents a function and explain your reasoning. Number 9 says that y is equal to x plus 2. The output is equal to the input plus 2. The plus 2 is the operation that the function is performing. We're going to plug in the input. We're going to add 2 using the function, and it's going to give us our output, that is our y. So the inputs are listed. -2, add 2, and get 0. -1, add 2, and get 1. 0, add 2, and get 2. 1, add 2, and get 3. 2, add 2, and get 4. So using our inputs, we plug those into our operation or our function, and it yields our output, which is the y's. And then you just complete the table. Is it a function? Yes. None of our x's were repeated, So we didn't have any duplicates. If you think about adding 2, unless you do the math wrong, you're not going to repeat anything. You're going to get the same number every time. So each input has 2 added to get the output. On number 10, y, or the output, is equal to 4 times x, or 4 times the input. So we take our inputs and we plug them in. -2 times 4 is -8. -1 times 4 is -4. 0 times 4 is 0. And 1 times 4 is 4. 2 times 4 makes 8. Now, is it a function? All of my inputs are only used one time, so yes, it is a function. The pattern is multiplying by 4. So each input is multiplied by 4 to get the output. It is a function. If we perform the same operation every time, we're going to get the same result every time.